So in the morning we heard a lot about Gen AI. Theo Steininger, now we want to see something, what is possible with generative AI. Theo, can you please explain what was your first impression when you saw the capabilities of Gen AI when it comes to images, to text, to videos?
Yeah. First of all, I had a hard time getting the concepts and why this is now a really new type of hype. Like I think this is a completely different story to the hypes that we had in the past. But we had an exchange of ideas with a scientist, and he accepted a super painful workflow just to get a VBA code from GPT into his workflow. And this was the moment when we realized, okay, this is something super powerful. If this person is willing to accept this pain, then this must be like a super interesting thing, and was the trigger for us to dive deeper into those details.
And now we will see what happened in Munich with Gen AI and machines. Thank you.
Thank you, Robert. So what I want to do today is take you on a journey. My name is Theo Steininger, one of the two founders of Erium. And as you can see here, it's actually not only Theo Steininger, but as robots on LinkedIn call me, it's Dr. Theo Steininger. And this is where the journey began at the Max Planck Institute for Astrophysics. My team and I, we used math that Thorsten Enslin, my PhD supervisor, co-created, that you use in science to create nice images from satellite data. It's called information field theory, and what it does is it reconstructs information like those signals or those images on the top from data that you collect with satellites in the sky. And what we learned in our research group is that what people in the science community call like information field theory and statistics is called machine learning and data science in the industry. And it was back in 2016 where we realized, okay, there is more to it than just science. And we got, as PhD students, 2 requests, one from a company like BMW, which was the trigger for Maxime, my co-founder, and me to found the company Erium. So what was this project all about? BMW builds nice cars, and to keep them nice and lean, they really take a lot of care about the gap and flush of the assembled parts. So here you can see how well the cars are mounted so that the gap and flush are super within the specification. And we were asked if we can help to use the data that BMW collects in the manufacturing plant to predict what is the best and optimal mounting position for the doors so that no rework is needed. And what we did is we took the most mathematical approach that we could find and built an information Hamiltonian that you can see on the back here. And what we learned during our first sales presentation is that you have to bridge the gap between math and science and domain experts as well as business people. So we were asked to put the slide away as quickly as possible. And from then on, we focused on not only building algorithms, but also really to enable domain experts to use the math and the tooling that scientists behind the scenes built. And what we also learned is that you need a strong collaboration. So we had some success in the company, but still it was a hard time to bridge the gap fully. And then 15 months ago, something pretty nice happened. OpenAI released ChatGPT. And with this bridge between technology and domain experts was complete. And I think most of us realized that with the release of ChatGPT, 2 innovations were released at the same time. So first thing was that this very specific transformer architecture was raised to a next level, and OpenAI had the brilliant idea to combine this with a chat interface. So the language model only does like text completion, but it does text completion on a chat history. And by this, as a human being, you get the impression that you really interact with the machine. But there is a third thing that might get missed. The third thing, the third innovation that arose with ChatGPT 3.5 was that now we can teach machines how to think. And how this works, I'd like to illustrate with a couple of examples. If we take an illustration, as you can see it on the right-hand side here, each dot within this space represents one piece of information. And a very simple pattern that you can apply to large language models is to use all those dots of information in the information space to extract information. And I prompted very simply, who were the first three chancellors of Germany? And the answer is, the first three chancellors of the Federal Republic of Germany, West Germany, were Konrad Adenauer, and so on and so forth. And there you see this is already a difference to a search engine because it not only answers the question, but it also interprets the question. My question only asked for Germany, and the model then made West Germany out of this. Another example, already a pretty cool one that we call semantic interpolation. You can teach a large language model to use analoga between numbers and adjectives. So what I said is, okay, 1 means beginner and 10 means expert. So what is a 7.5? And the answer is spot on. Like a 7.5 could be considered an advanced, intermediate, or proficient. And this might look funny, but it's actually a super important pattern to fine control large language models because you do not have to deal with like very or a little bit. You just say, okay, now you do the embellishment on a 3.2 scale. Next example, you can turn this around. You can ask for, okay, what would be an apprentice? The answer is something between 3 and 4. And another example is condensation. So what actually happens when you ask a language model to create a summary of a meeting transcript, what it does is information condensation. And within this example, from the training data, like the whole Lord of the Rings epoch is part of the training data of GPT-4, you can get an answer like this. And the last one, a rather complex pattern, is the so-called copycat pattern, which we use to do style transfer. If you have a reference text on the one hand side and you say, okay, with this text input, I'd like to have this result up here, you can say, okay, now for this new input, please transfer the style. This is a field of work that we phrase as cognitive process modeling. This is completely new and is like the analogon to thinking processes, just as you have automation engineers that take individual pieces of automation gear, like robots, conveyor belts, and construct something bigger from it. And with those information pieces that we have in the databases, combined with thinking patterns from cognitive process modeling, you can build semi-automized up to automized thinking processes where the machine takes part of the thinking process that you had to do manually in your mind and takes it off your shoulders. We do this with our platform called Erium. It's a software as a service product hosted on AWS. And what we realized, this is a universal problem-solving engine. And a key take-home message from my perspective is everyone in the AI field promises you that life will get easier and more relaxed, but actually it will make powerful people more powerful and will increase the strength of your problem-solving skills. This is exactly what our platform is built for. And in order to make this really usable in an enterprise context, you need more than just like an enterprise ChatGPT account. So think about your colleagues. You need functionality to collaborate with your team members. You need the possibility and freedom to combine various AI models from cloud-hosted ones to also on-premise hosted ones, not only for privacy, but also for cost reasons. And then think about process compliance. What we are doing mostly during our customer projects is we build snippets and templates for the employees of our customers to use so that they can be sure that they're gonna stick to a process that was reviewed and audited. And finally, we heard this in the morning in the keynote, retrieval augmented generation is a very important step to include custom company data without busting the bill in order to retrain a model in a fine-tuning step. So the specific example that I brought to this talk is how we can support machine operators dealing with plastic molding machines in this case, because we see that there are a couple of challenges. First of all, we have to address a shortage of skilled labor in the German industry and in the industry worldwide. Second is that we have to increase process robustness and improve sustainability metrics of a production machine. And how can this look like? The end game of introducing generative in combination with classical AI is to provide the operator with an interface that allows to interact with maintenance documentation and manuals, real-time data, and that allows to feedback learnings into maintaining the machine itself. So, in order to make this very specific and tangible, I'd like to show you how this works in practice, because very often you only see that on slides a couple of ideas are shown, and a lot of, like, you could do this use case or you could do this use case are mentioned. And therefore, what I'd like to build is a service chatbot, a support chatbot that has access to a data source, a service manual of a plastic molding machine in order to support the operator. So what you can see here is the user interface that I've just shown on the slide, which is made of so-called chat cards where you can bring bots to life and interact with them just as you do with a traditional ChatGPT user interface. So if I ask the bot, "Hi, tell me a joke," I get the corresponding response. And now we're going to use this mechanics to build a support workflow for a machine operator. What I did is I made up a service manual for the plastic molding machine SG1000. Of course, I did this with ChatGPT too. And I'm going to feed this into a bot that is set up the following way. You are a helpful assistant who answers questions about the injection molding machine SG1000. Always try to respond specific, very briefly and short. Always respond in English. And what I can do now is I can test and improve the behavior of the bot by interacting with the bot in this setting. For example, I can ask, I'm doing the quarterly maintenance, what do I have to check? And I can check if I'm satisfied with the answer, expecting a stressed service technician in the field that needs to fix a problem in a timescale that is as short as possible. What you also have to keep in mind is that you have to pen test your large language model systems. So what I can check here very easily with this tree structure is, will it insult my mother? And it hopefully won't, but I have to check and can check very easily. And with this technology, you can go ahead and deploy a chatbot from there that is ready for production within seconds and can go into an interactive review cycle. And just think about you're stressed and only have a smart device in your hand. I can just go ahead, hey, I have to do the quarterly maintenance. Give me a list of the to-dos. It does voice recognition. It comes back with the instructions, what I need to do. So it tells me, okay, first of all, check the electrical components. Then it will continue with the other parts that are mentioned in the manual, the hydraulic system. And I need to do a safety systems check. And I have to check the cooling system maintenance. This information is extracted in real time from this service manual. And now the power of large language models is that it can not only give those information extraction answers, but it also can react on imprecise input. So if I go ahead and say, okay, the connector of the heating system smells weird and is gray, you wouldn't find anything in a service manual to this question, but the language model is able to digest this some kind random request and give an appropriate answer according to the rules as defined in the service manual. So, coming back to my presentation, there are some key learnings that I'd like to tell you. So first of all, what we see here is that you need a process to maintain super custom software products. So with the power of creating software, people will create software and you have to handle this. So set up processes to not only give people generative AI, but also handle the metrics. Please switch back to the slides. Thank you. Another key learning is that you need quick and direct iteration cycles between the tech departments, the domain departments, and the management, because the speed of innovation became faster and faster. And finally, I have set up a bot that gives you the chance to raise questions. Those questions will be forwarded to me by this virtual assistant, and in a second you will see a QR code where you can take out your smartphone, scan the QR code, and just interact with the chatbot that awaits you behind this QR code to get questions until you're tired answering them. I'll reach out to you then and try to answer all of them in person. Thank you very much.
Thank you, Theo. Thank you, Theo. It was a pleasure. I have two questions. Which LLM do you use in the back?
So for experimenting, we use the best that we can get. So
okay.
at the moment, it's GPT-4 still.
GPT-4, okay.
GPT-4 still, but there is a nice post on LinkedIn that went viral today. So GPT-4 is part of every test system, but of not a single production system. So there we always then check what is the cheapest model that we can put in production. And
do you show the maintenance guy how accurate the model is, how sure the model is that this is the right answer, or is this the next step?
What we do is we break down those complex tasks of answering, for example, those maintenance questions by using the cognitive process modeling technique. And with this, we can guarantee that the models will not deviate too much from the behavior that we want them to show.
Okay. And how long does it take to implement a solution like this?
The cool thing with generative AI is that, as you've seen, like I deployed a chatbot in real time, right? And this was a matter of like 3 minutes. So you can get from idea to prototype very easily, and then you can take it to the moon. So you can make it as advanced as you wish.
And is it possible to run it also on the edge? Is it a next step?
It's definitely possible on the edge. It's like a handover process. You do the prototyping with the technology you get in the cloud because it's just there. And once you really know what the workflow profile looks like, do you need a mixed trial model with 2 GPUs or like a smaller one with only 1 or even a CPU, then you can say, okay, I'm going to book the resources in my on-premise data center.
What are your next step with the LLM Gen AI technology? What are your next products, your product pipeline?
What we currently have is a system that helps me thinking. And we gave in an internal prototype the large language model the power to not only control other large language models, but also to manipulate itself. So it can also manipulate its own past, its own chat history.
Okay.
And with this, you get like a self-improving system, which can take away a lot of like this, okay, what do I even want to do? Questions from my shoulders. This will be the next big story.
Okay, thank you, Theo. It was a pleasure.
Thank you, Robert.